So the principle, very important thing, the principle is this experiment use the method which is based on the study of the motion of uncharged oil drop under free fall due to gravity. See that when you just spray oil drop, it will be falling under gravity. So we are first studying motion of the uncharged oil drop in the gravity, then charged oil drop in uniform electric field. By adjusting uniform electric field suitably, a charged oil drop can be made to move up or down or even kept balanced in the field of view for sufficiently long time, and series of observations were made. The oil drop experiment consists of a vacuum box and two parallel plates are there. So in the parallel plates, the upper plate consists of a hole. Through that, using the atomizer, we are spraying the oil drops. The drops are falling down. We can visualize with the help of the lens, and the light can be focused here, and we can see with what velocity the drops are falling down. So we can pause the light and study the velocity of light. Now we are applying the X-rays. X-rays are passing through this one. So the air in between the plates will be slowly ionized. Now what happens? The air is ionized, so the ions are carried by the oil drops, and we are applying the field between the two plates. So the drops are now moving up. Slowly it is moving up. So we can ionize the air, and the drop velocity can be now calculated. We can measure the time taken for a drop to move in the upward direction. So the oil drop was freely falling down. Then when we apply the electric field, it is when we apply the X-rays, the ionization was done. Then apply the electric field, the oil drop is moving in the upward direction. So without field, the drop is falling down. Then when we apply the field, it can be moved up also. So the two methods are there, two parts are there in this experiment. First, free fall of the drop, and then it is moving under field. Both motions can be explained in an elaborate manner. The force induced is given by the Maxwell's right-handed corkscrew rule. If a right-handed corkscrew is rotated to advance along the direction of current through the conductor, then the direction of rotation of the screw gives the direction of the magnetic lines of force around the conductor. Now see the diagram. When current is passed through the straight wire, circular lines of force induced. Now when we pass current through a circular loop, within the coil at the center, uniform lines of forces are created. And in this end, the current is coming out, so the lines of force will be in the anti-clockwise direction. Whereas at this point the current is moving in this direction, current is going to the inward, so the lines of force produced will be in the clockwise direction. So the depending on the direction of current through the conductor, the lines of force are induced. Current is in the upward direction, lines are in the anti-clockwise direction. The current is in the downward direction, the lines of force is in the clockwise direction. So this is in accordance with the corkscrew rule. A cardboard is fixed in a horizontal plane. A circular loop of wire passes through the two holes in the cardboard as given in the diagram. Iron filings are sprinkled over the cardboard. Current is passed through the loop and cardboard is gently tapped. It is observed that iron filings arrange themselves along the resultant magnetic field. The magnetic lines of force almost circular around the wire where it passes through the cardboard. Whereas at the center of the loop, the lines of force almost straight and perpendicular to the plane of the circular loop. That shows the uniform field. Now, Byers and Savart law gives the magnitude of the induced lines of force or magnetic induction. Now, let us consider a wire XY and when current is passed through the wire I, passed through that one, let us calculate what is the magnetic induction at P. So from a small element dl, that is AB, the point P is at a distance r, and that element is making an angle theta with the vector r. So the magnitude can be given by Biot and Savart law. Biot and Savart conducted many experiments to determine the factors on which the magnetic field due to current in a conductor depends, and the results are summarized and given as Biot-Savart law. According